Okay, I'm going to do a quick video on sum and difference of cubes. So it's factoring a sum of cubes and a difference of cubes. So here we're going to first come up with a formula, and then we're going to apply the formula to the following problems. You have to memorize this formula. This is the sum of two perfect cubes, because u times u times u gives you u cubed. V times v times v gives you v cubed. This is a sum, this is a difference, so that would be the sum of two cubes, the difference of two cubes. If we had a difference of two squares, like if we had u squared minus v squared, remember there's kind of a formula for that. You would say u plus v, u minus v. You can only do the difference of two squares. If I had u squared plus v squared, we can't factor that. It's not factorable. So just keep that in mind. When we have sums of cubes, though, we can factor it. So this is the formula that we're going to use. You just have to memorize this. It would be u plus v. So it's the what times what times what gives me u cubed. Well, what times what gives me u cubed is just u. What times what gives me v cubed is v. So you take the cube roots of each of these, and you just say u plus v. I like to write them on top, what the cube root of each of these are. And then we're going to take u squared plus uv, u times v, plus v squared. And I've messed up already. This second sign right here has to be the opposite of the first sign. So this sign is whatever, these two match, and then this is the opposite, because when we multiply these together, either taking u times all three of these, v times all three of these, or lining it up underneath here, we need to come back with this. If we multiply these two together, we would get this. That's what factoring is. It's splitting it into two things that when you multiply it together, the things are called factors. When you multiply the two factors together, you get what you started with. So you need a negative because it needs to shrink somewhere along the way. Okay, the difference is the same thing, only it would be u minus v. See how they match the first one? And then the second sign is opposite of the first sign. And the last sign is always positive. So let's apply these to some problems. This is your formula that you need to memorize to do these problems. For some reason I'm not writing. Here we go. I don't write on top of the formula, that is. Okay, so let's just do, this one's exactly the same as the first one. This is number 1 on your worksheet, worksheet number 6. So we say, what's the cube root of x cubed? That would be x. Cube root of y cubed is y. And then you just plug in the formula. So it's this plus this, the first number plus the second one, x plus y. It's the first one cubed, squared. So it's going to be x squared minus these two multiplied, and I messed up already again. This is going to be minus, okay, because they have to match, and then this is going to be plus, so it's going to be xy plus the second term squared. That one's not that helpful because it's just like the formula. Let's go on to this one. This is a difference of two cubes. We would say what times what gives me 8x cubed. Or you could say what's the cubed root of 8x cubed. Well, 2 times 2 times 2 gives me 8, and x times x times x gives me x cubed. 1 times 1 times 1 gives me 1. So you just put them in. Wherever there's a u, you put 2x. Wherever there's a v, you put 1. So we're just substituting in for the u's and v's. So u is 2x. It's minus, let me get that right this time, v, this is v, so it would be 1. Now it's going to be the first one right here squared, so it would be 4x squared, plus those two guys multiplied together, so it would be 2x. And then the final guy, cubed, squared. That's why that's always positive, because you're squaring a negative, so you're going to get 1. And that's how you do these problems. Now they start getting a little bit more complicated as you go down the sheet. So what times what gives me 64a cubed? Well, it would be 4 times 4 times 4, a times a times a, 3 times 3 times 3, b times b times b, and then you just fill it in the formula. This is your u, and this is your v, and you just plug it in. So u squared would be 16a squared. These are all minus that I picked. Isn't that interesting? Minus this one squared, this one. I did it wrong again. It's just u, it's not u squared. So it's just 4a minus 3b. Now it's u squared, so it's 16a squared. These two multiplied together, 4a times 3b is plus 12ab. And then the second one squared is 9b squared. And that's how you factor it. If you would multiply this times this, you should get this. So you can always check it, but it's a lot of work to check these things. Okay, this is a b. That looks like a 36. Okay, here we go. This one looks similar to this one, but it's, you can see the exponents are to the 6. So what times what itself 3 times will give you x to the 6. Well, it would be x squared times x squared times x squared, and y squared times y squared times y squared. So our u is x squared, our v is y squared. So we just plug it in. It's u times v, x squared minus y squared, because u is x squared, v is y squared. Now we square the first one. X squared times x squared is x to the 4th. We multiply these two guys together, x squared, y squared. And then we square v, which is y squared, so we get plus y to the 4th. I think I only have one more to go, and then we'll do a couple on the worksheets and see if we get the same answers. So what times what gives me 27? So that's 3 times 3 times 3. This one's pretty tricky. What times what gives me p to the 12th? Well, if I have p to the 4th cubed, don't I get p to the 12th? And q to the 3rd cubed gives me q to the 9th. This one here is a little tricky. I'm just going to show you how I would do these. Let me see if I can find my calculator. Okay, some of these numbers are big. You can use the cube root function on your calculator to find out the cube root of 343, or you can just start guessing around. Like you could say, 10 times, let's try, like if I do 6 times 6 times 6, I get 216, so that's too small. We can do 7 times 7 times 7, and it gets me 343. We got pretty lucky. So it's 7. So this is going to be 7. R squared, because r squared times r squared times r squared is r to the 6th. Or you could say r squared cubed gives me r to the 6th, and then just f. So this is our u, and this is our v, and we have to just plug it into the formula. So it's u minus v, so it's 3 p to the 4th, q to the 3rd, minus v, which is 7 r squared f, times, I'm going to run out of room, so I'll go down here, times u squared, which would be 9 p to the 8th, q to the 6th. Then these two multiplied together, plus 21 r, okay, we have all these variables we have to deal with, so let's just go in order. P to the 4th, q to the 3rd, r to the 2nd, f. So I just multiplied all these variables together, and then we square the v. Plus 49 r to the 4th, f squared. And that is your answer. There's a couple with fractions and so on. Let's try 19. Let's do one more, because I wanted to show you one with positive. 729 m to the 6th plus 64 n to the 15th. I'm going to need to use my calculator again. Last number was 343. So first we want to find out our u and v. So I'll just do it down here since I have more room. U, so get our calculator out again. And you can start guessing. Last time I did 7, let's do 9 times 9 times 9. 729. I hit it right on. So it's going to be 9. m squared cubed gives me m to the 6th. Then 4 times 4 times 4 gives me 64. And they have a 15. That's a little bit challenging. So that would be n to the 5th cubed does give me 15. If it's divisible by 3, it's a perfect cube. For exponents only, not for the number part, because with our exponents we multiply. So this is our v, and once we have that we can just plop them in. So we have 9m squared plus, so it's going to be plus 4n to the 5th, because it's just u plus v in the first one, u plus v. Then it's this one squared, so it's 81 m to the 4th. If this one's plus, this one has to be minus, so it'd be 36. Multiply these two together. M squared, n to the 5th, and then square this one, plus 16 n to the 10th. Okay, we're gonna square this, and so when you square it, it's not going to be 25. If we took this and squared it, 4n to the 5th squared. See how we're going to square the number and get 16, and then we multiply exponents, so it's n to the 10th. So keep that in mind, that's a little bit tricky. Okay, we're going to do some together as a class on our video now, so that's it.